Well, I have a few questions here that I need
Okay.
to ask. And the first one is, this movie that we watched, it really got us up in arms about fracking and the fact that it requires a huge amount of water. In our area, that water is going to come from the Susquehanna River Basin. How's that going to impact our river?
Typically, for unconventional well that you're producing through hydraulic fracturing, the hydraulic is code for water, so it uses water as a part of the fracturing process. A typical well uses anywhere from something like 2 to 8 million gallons of water to do the fracturing process, which is a lot of water. It's a lot of trucks, it's a lot of delivery, depending on where you get the water from. And that's conducted to move at high pressure through the formation to actually induce cracks or fracturing into the shale. And while that's a lot of water and it's used all at once, it puts some of the wells into competition for local water supplies, depending on where you are. Some production is in urban areas, and you might be competing with homeowners, other people want that water as well. So that's something that's very sensitive for people, how much water you use for the shale gas wells. But in the end, the amount of water you use for that well over the lifetime of the well is actually quite low. So one of the things we find is that the water quantity requirements for shale gas production is actually lower per unit of energy produced than a lot of other choices like petroleum or coal or nuclear.
Really?
So it ends up being pretty water lean in the end, but use all the water at once in a local area over a few days, so it feels like a lot of water.
So that's a major benefit for natural gas.
One of the benefits of natural gas is that from a water quantity perspective, it's more water lean than other options.
And the same is true in other areas of the country as far as the consumption?
Yeah, the amount of water you need for the well varies by some millions of gallons of water, depending on the geological formation you're in. So, even if it's 8 million gallons out of 2 million gallons, it's still relatively water lean, so that's good news. If you're in an area, however, where you don't really have that water, then water scarcity is real and needs to be attended to.
So I've got this straight, that the impact on the water needs is relatively low for natural gas compared to any other sources of energy that we might go into.
Compared with most sources, so solar PV, photovoltaics, and wind are even leaner from a water perspective. So it's not the water leanest choice, but it's leaner than most choices. When we think of the different fuel choices we have, they all need water at some point, either to produce the fuel, to refine the fuel, to burn the fuel and cool the power plant using that. And so we can go through all the fuels and look at how much water they use. And it turns out that nuclear ends up being very water intensive, primarily because of the water used to cool the power plant. One thing we like nuclear power plants to have is all the cooling they need. And we achieve that cooling through water. So we use a little bit of water to produce the uranium when we get it out of the ground, to refine the uranium or enrich it. And then when we use the uranium in a reaction to get heat, it's actually boiling water, then we use water to cool the system. So nuclear fuels end up being pretty water intensive from a perspective of how much water you need per megawatt hour you produce. Solar thermal is actually very water intensive as well, because you use water for water cooling. If you have a thermal plant, we're using water to make heat, to boil, to make steam, to run a power loop. Then coal is the most water intensive, primarily because of the water at the power plant again, but you also use water to produce the coal at the mine. Then natural gas is next in line, or maybe along order with petroleum, in terms of using water to produce the fuel out of the ground, then using water to cool the plants that refine it or improve the fuel to get it ready for combustion, and then at the power plant. And natural gas is tricky because we use natural gas at power plants and in transportation and in direct heating. And at power plants, we use it in a variety of turbines, and some turbines are very water intensive and some are not. And then we have solar photovoltaic panels and wind turbines, which they use some water when we're making the metal or making the turbines and panels, but they don't use water during the process. So if we have a hierarchy, different fuel choices, they all use water to some degree, and some use more than others, and natural gas ends up being relatively lean from a water perspective, which is it's a good news story.
Sounds good. Now, as far as the natural gas industry, do you think it's regulated enough?
Is the natural gas industry regulated well enough? It depends on what question. There's a lot of regulatory questions. There's fair trade practices, there's water protections, there are air quality protections, and there are a variety of regulations that are relevant, and some are adequate and some are not, so there's no single answer, and the regulations vary state by state. So one of the challenges for the natural gas industry, and I would say it's a challenge for the industry and also a challenge for regulators, that the regulations are different in every state. And there are also federal regulations as well. And because of the lack of uniformity, it's actually difficult for natural gas companies because they don't have one set of rules to follow. And it's also difficult for the local populations because no one's rules are the same. Then in some states you have county by county regulations that differ as well. So the answer is yes, they're regulated appropriately and well enough in some places, but not everywhere. And then they're regulated well enough on some questions, but not all questions. I think, for example, on climate change issues, natural gas is not regulated. No one's regulated for climate change, essentially. We don't really have a carbon policy in America. So I would say natural gas is not well regulated from a carbon perspective, but it might be well regulated on other avenues. Okay, so on the water quantity question, there are these millions of gallons of water we need for every well, which is a lot. It can put you into competition with other needs and sources in the local area. And a lot of people worry it'll drain the river or drain the aquifer. And generally the answer is it won't. Although there are some watersheds that are very sensitive and there's just not the water available. And in those sensitive watersheds, you probably shouldn't be doing shale gas production. But in most areas, it's generally fine. And by most calculations, depending on where you are, the shale gas needs for water tend to be far smaller than what the city domestic needs are, the municipal needs, or other industrial needs. And then when you compare that to agriculture, typically agriculture blows it away, depending on where you are again. So the question about water quantity is partly a function of how much you need for that well. You have to compare that to how much water you have available and what the other demands on the water resources are. And quite often, the water problem from a quantity perspective is not a big deal for shale gas production. And that's not universally true, because if you go to a desert area where there's not much water, or there are other demands for the water, you might come into conflict. Another issue for water is water quality. Just because you have enough water doesn't mean that you can do it or that you should do shale gas production, because you have water quality risks that are very real. And there's basically a couple of different risk points you have to worry about. Generally, if this is the ground, you have groundwater 500 feet below it, say. And then below that groundwater, another 6,000 feet might be the shale. And as you drill through the groundwater to the shale, then turn your drill bit sideways to fracture the shale, you are penetrating the groundwater system. You could actually introduce pollution through the well to the groundwater, either by the chemicals you put into the system or by the naturally occurring chemicals that come back up. And there's an easy way to deal with that. It's just case your well in cement. And if you case your well properly, you should not have much risk for groundwater contamination there. Another challenge is that if you have your groundwater in your shale, and you brought all your junk up, because you bring water back up, and that water comes with benzene, arsenic, or whatever is naturally occurring, plus whatever chemicals you put in, that water comes up to the surface. Some people put it in a pit nearby, and if you don't line your pit, the water that's contaminated can trickle down into your groundwater. So you can either affect your groundwater when you're bringing things up if you don't cement your well, when you're injecting fluids if you don't cement your well, or when you bring things up and put them in a pit if the pit is not lined. And so these are two very important risk entry points for contaminants to the water supply that I think we as a society and natural gas producers and anyone who drinks water should take seriously. But there are also problems that can be solved through good engineering, good policy, and best practices. If companies are operating the right way, it's not a problem. And if they're using people they haven't trained or aren't supervised or have sloppy practices, it's a risk factor. So we have to worry about water quality and water quantity, and both are real issues and both can be mitigated, is sort of the idea. The global challenge, the macro trend for energy, is that we all like energy, we all like water too, and we have population growth in America and globally, and we're getting richer. And as we get richer, we consume more energy and water per capita. We eat more meat, we like more electricity, we do things that are more energy intensive, and we're growing in population, so we have a compounded or exponential growth overall. The demand for energy is going up faster than the rate of population. And that's an American phenomenon and a global phenomenon. So the tension or competition for resources is only going to intensify. And then we have these challenges where even among the resource options we have today, they all have downside risks. They pollute too much, or they're not affordable, or they're not easy to operate, or they're dangerous, or they're imported from countries we don't like. And as we come up with solutions that we think work, we have to balance three different priorities. So if we look at our global choices and we're trying to balance the three priorities, having an energy source that's clean, domestic, and economically abundant enough to meet our needs, most fuel options meet one or two of those priorities, but not all three. And natural gas historically has been considered here and clean, and it used to be abundant, but then we were worried we were running out, and then we were worried that we would have to import some. But today, with an abundance of unconventional resources in the United States, it meets all three priorities. It's one of the few options that actually can. Natural gas is a big enough opportunity that we would be foolish not to harness it. But the risks are very real, and we'd be foolish not to address them. So that's the global story on natural gas.